Welcome to lectures on problem solving and programming in C. This is the 11th lecture of the course, and the title of the lecture is Problems on Sequence of Numbers. Suppose if you want to compute maximum marks of a class, so we can read marks of students one by one and maintain the maximum marks of the class. So like this, there are few problems on, we can see few problems on sequence of numbers of coming one by one. And then at the end, we have to give out some properties of the numbers entered. For example, sum of the numbers, average of the numbers, maximum, second maximum, like that. Problems on sequence of numbers. These are the problems we are going to discuss in this lecture. Maximum marks of a class. In this case, we have two cases. If you know the number of students of the class a priori, if you know that there are 100 students, then I can read 100 marks exactly from the user and display the maximum marks of the class. But what if I don't know the number of students a priori? So that is why we have a special repetitive statement called sentinel controlled repetition. What we do is we keep on reading marks until user enters a sentinel value. Sentinel value is a special value which indicates that end of the data. Here we no need to know the number of students a priori or number of numbers a priori. We keep on reading the numbers until the user enters a special value which is called sentinel value. So sentinel value indicates that it is the end of the data. Then we can figure out sum or maximum marks of the class. What is the average marks of the class? Well, to compute the average marks of the class, we need to compute the sum of the marks of the class, then followed by number of students of the class. So these two problems we will see, these three problems. So let us talk about the first problem. So what happens is if numbers are, suppose if you know that 5 students are there, 5 students. Okay, I read 5 numbers, say 50, 70, 60, 80, and 70. The maximum is 80. Okay, so I keep on reading the numbers one by one and maintain the maximum marks of the class. Okay, so the first case is number of students. N is basically number of students. Number of students. Students is input. First, we will read the number of students and then validate it. If it is more than one, then we read n marks from the user and display the maximum of the class. What we do is, in this case, initially 50, we read 50, right? So 50 will be max is 50. Okay, next when we read 70, previous max was 50, but 70 is more than 50, so we'll discard this and maintain, keep it update to 70. When 60 comes, 70 is already maximum. 80 comes, 70 is no more max, 80 is the maximum. And 70 comes, 80 is the maximum. So it means that when you read a number, we keep on reading numbers one by one, and at any iteration, we will maintain the maximum we have seen so far. Up to here, the maximum I have seen so far is 70. Up to here, maximum so far seen is 70. Up to here, maximum seen so far is 50. Up to here, maximum seen so far is 80. So whenever we get a new maximum, the maximum will be updated. So by the time you process the last number, the maximum is already available to you. So remember, we no need to store all these numbers in the memory. We need 1 marks by 1 marks, and then once you need a second mark, the previous mark can be discarded. Okay. Of course, there may be instances where we need to store the entire marks of the class. And then because we may have to do a lot of statistics, but that is not our requirement at this moment. We just have a space for couple of variables, few variables only. We cannot have a space for storing all the marks of the class. Okay, because we have not reached that stage in the class of the course, right? So let us develop an algorithm. So algorithm, some max marks. Okay, input n greater than 0, comma, a sequence of n marks. Output maximum marks of the class. The class. Okay, begin. So input n, n. So we need to validate n because n is expected value of n is greater than 0. If n less than or equal to 0, then output invalid input. Stop. And if. And if. Otherwise, how many marks we need to read? We need to read n marks. So n is at least 1, right? So what we can do is we can read marks, input marks. First marks are read. Okay. Then, so I will assume that max equal to marks. The first, when you have only one student, his marks itself is the max. Since we have read one marks of one student, we need to read the remaining students which are for I equal to 1 to n minus 1 to 2. Okay. Input marks. If marks if current marks are greater than max, then we need to update the max. Max equal to marks. And if. And for. And output max. And end. Okay. See, we are talking about marks. So it can be negative, positive. We are not really caring about that at this moment. But if you want, we can even add a input validation here. We can add input validation here. If the marks are negative, we can read again, or we can stop the program. So if the marks are invalid means, suppose if you are assuming that marks range of the marks is 0 to 100, if anything other than that is entered, you can stop the program. Such a condition can be added here and here. So at this moment, we are not bothering about that. Okay, this is simple. So input n is read, and then n less than equal to 0, invalid input on stop, and then first marks of the first students are read. This is marks of the first student. And then when you read the marks of the first student, if the only one student is there, then his marks will be the highest. Then we need to remaining number of students are n minus 1. So we need to read n minus 1 marks of the n minus students one by one. Then when you read marks, you will compare the marks with the current max. If the current marks are more than current max, we need to update the max to hold the current marks. Okay. After that, we will display output max. What is the observation is, here you know the number of students of the class n. Okay. What if you don't know the number of students of the class? That's where the sentinel control repetition comes into picture. What sentinel control repetition? Sentinel controlled repetition. Okay, so this is basically I don't know how many students are there in the class, but I want to complete. What I can do is I read marks one by one, and if if user enters some positive number, I'll treat it as marks. If user enters some -1, okay, -1 for some special value, -1 sentinel value, I will assume that this is the end of the input. Okay, then I will come to know how many marks the user has already entered. So there I will stop the algorithm. Okay, so then algorithm, sorry, algorithm max marks sentinel control repetition input. Here we don't have input n, we have only a sequence of numbers. Sequence of numbers followed by -1. -1 indicates that it is the end of the output. Maximum marks of the class. Maximum marks. So input, sorry, begin. So here what we can do is we keep reading the marks, okay? We'll read the marks. First we'll read the mark. Input marks. Okay. Max equal to marks. While when one data is read, we need to keep on reading other marks. Input marks are -1 to enter. While marks not equal to -1 do. Okay. So input marks if marks is greater than max, then max equal to marks. And if and while. And while. So and then output put max and. So this is basically this is reading the first marks, and then this while loop runs as long as user enters anything other than -1. If user enters -1, so we stop the program, then maximum will be displayed. Okay. So this is called sentinel control repetition. This is called sentinel control repetition. This is also called indefinite repetition. Indefinite repetition. Because we don't know at the start of the while loop, we don't know how many times this loop is going to be run. Because based on the user input, the number of times the loop runs is determined. It's not we don't know at what time, how many times this runs. Whereas here, if you see here, with this loop This loop runs exactly n minus 1. We know that. So that is why this is called definite repetition. Definite repetition. Definite repetition. This is indefinite repetition. This is also called sentinel control repetition. Sentinel control or repetition. So while loop is also called entry control repetition, right? Entry control repetition. Whereas do while loop is called exit control. Do while loop is exit control. And this for loop is also called um, counter control repetition. Counter controlled control repetition. Because this loop is run by a counter variable called I. That is why it is called counter control repetition. Definite repetition, where before start of the loop itself, we know how many times the loop is going to run. Counter control repetition, where the loop uses a counter variable to iterate through the loop, like I for I equal to 1 to n, like that. Then there is a indefinite repetition, where at the start of the repetitive statement, we don't know how many times the loop is going to be executed. So that is called indefinite repetition. And this is also, so if you are using a sentinel value to terminate the loop, so it is called sentinel control repetition. While loop is called entry control repetition, and do while loop is called exit control repetition. These are different kinds of repetitive statements. Let us see what is the next problem. We have done this and this, done this. Average marks of the class. Average marks of the class. So we will see an example here. Okay, sum average. So this is uses sentinel control repetition. Okay. What is the algorithm name? Sum average. Input is a sequence of positive integer numbers and -1 to sentinel value, as sentinel value. -1 to indicate the end of the value. Output is sum and average of numbers. Okay. So since we need to compute the sum of the numbers, and count number of students, what we need to do is we need to initialize the sum is equal to 0, count equal to 0. And then since we can use a do while loop. Do while loop is the best fit for the sentinel control repetition. Okay. So enter a number greater than 0 or a -1 to exit. Input number. If number is greater than -1, greater than equal to -1, sum equal to sum plus number, count is incremented. Okay. Sum is added and count is incremented. Else what happens? We will display that invalid input, enter a number greater than equal to -1. In this case, valid inputs are minus. We are talking about positive integer numbers only, 0 or more. So whereas the -1 is a special sentinel value. So valid inputs are -1 to -1 and more. Okay. So if anything other than -1, less than -1 is entered, it is invalid input. So we are not terminating, we are reading again and again. Okay. User enters a correct number. So and then since here, if the final case, if an user enters the -1, the sum and count is also entered. That is why sum we need to subtract, add +1 to sum and -1 to count, because count is incremented, sum is decremented by 1 because number is -1. So sum is +1 and count is -1. By this time we have some of the numbers entered by the user, and then number of numbers entered by the user in the name of sum and count. If count is 0, so we are giving a special message saying that zero numbers entered. How many numbers entered? No numbers entered, right? You should be no numbers entered. No numbers entered. Whereas if otherwise, what we will do, you will display the sum, and sum by count is the average. Okay, sum by count is the average. Like this, we can determine So this is an example where we are validating the sequence of inputs also. So if here in this case, what is the valid input? Valid input is anything other than greater than -1, greater than equal to -1. Anything other than -1 will be less than -1 will be an invalid input. So we are not stopping the program, because what happens is you have read 5, 6 numbers and then you entered an invalid input. So stopping that is not a good option. So we continue by reading the number again. This is such an example, right? So average marks, maximum, second maximum of marks of the class. So maximum, second maximum of the class. This is an example. Maximum and max2 are set to 0. Count is 0. Enter a number greater than equal to or -1 to exit. If number greater than -1, then it means that it is a valid input. Otherwise, you will display invalid input. Invalid input, and we are exiting. Okay, invalid input. Okay, invalid input. We are continuing again. If the number is greater than equal to -1, count is incremented. So here in this logic, we will update the, if number is greater than max1, it means that max2 is, we need to, earlier max1 will be max2 and max1 will be current number. Otherwise, if number may not be greater than maximum, but it can be greater than max2. So in that case, we'll only update max2. Like that, when a number is read, we will try to update the max1 and max2 of the numbers seen so far. Okay. Then by the time this loop is completed, we have max1, max2, and the count is, since we are counting one more time for a number is greater than -1 also, that's the count is decremented. Then we'll display the maximum and maximum 1 and maximum 2. If the count is 0, no numbers entered. If the count is 1, only one number entered, and we'll only display the maximum. Otherwise, total number of number entries count, and then maximum, max2 are displayed. This is a problem. So I think I will write a program for this problem. One of these problems. Let me write a program for this sum and average. Okay. Here is sum avg.c. Sum avg.c. Hash include stdio.h int main return 0. So what is the first statement of the problem? So sum is equal to 0 and count is equal to 0. Sum and count, we are talking about numbers, integer numbers only. So sum and count should be integer. Int sum equal to 0, int count equal to 0. Okay, I can combine these two like this. If instead of typing like this, I can put a comma and then remove this extra time like this. This way we can optimize the declaration. And then do while loop. We have a do, begin, end. This is the while, do while, number not equal to -1. Number not equal to -1. Semicolon. This is how you type a do while loop. Semicolon is mandatory as per the syntactic requirement. Since the number is compared here also, we need to declare the number also outside. Int number. Int number I will declare here. Comma number. Right. So what we need to do? Output to enter a number or -1 to exit. So it is printf. Enter a number greater than or equal to 0 or -1 to exit. This is a message, user message, friendly message to the user, so that he will aware that what he needs to do. Input n. So input n means a number is already declared, right? Input n input number is already declared. We just need to scanf. Scanf %d ampersand n. Okay. Right. Next, if number greater than equal to -1, if I will write differently here. Number greater than or equal to 0. This is the valid input. Valid input. Okay. Number greater than equal to 0. Then sum equal to sum plus number. Count plus plus. We can do count plus plus. Count equal to count plus 1 is equal to count plus plus. We can do a count plus plus. Okay. Else, when do you display invalid input? Else, if see here we are already any number is greater than equal to 0. But what happens if -1? We will anyway exit, right? So here we will do a break statement. There is a break statement. If okay, else if number not equal to -1. See, number greater than equal to 0 is a handle, so it can be -1 or less. If it is not equal to -1 means it is invalid. So we should display output printf. Printf invalid input. Enter a number greater than or equal to -1. Okay. Then if statement is done, we are done with the if statement. Then after that we have everything is done, right? Since we have not added we have modified this if condition, we no need to do these two statements. So we straight away write this: if count equal to 0, if count is equal to 0, then count equal to 0. Output no numbers entered. Enter no numbers entered and stop. Else we need to output sum and sum by count. Enter %d sum equal to %d comma average equal to %lf double. Okay. So here, so we need to display sum right, sum and sum division count. Okay, but what you need to understand is, so these sum and count are both are integers. In C programming language, integer by integer is an integer, and the fraction value be discarded. So to make it happen, what you need to do is you need to scale it to double. Then only you will get sum by, then it will convert to floating decimal number. Okay, let us run this, save it, GCC sum average, run undeclared first use in this function. Okay, I think we need to modify it to number. It's not n, it's number. Insert in number. So if you see /a, there are numbers. Let us give the same number again: 100, 50, 50, 50, 50, 50, 50, -1. You see here 200 average is 50.00. Okay. Let us give something numbers: 10, 20, 30, 40, 50, 60, minus 20. Minus 20 if you add, no, it will ask invalid input, enter a number, minus enter a number, or 0 or -1 to exit. Okay, so then -1. 210, 35.0. Right. Like this, this program, we translate this program like this. Okay. This is called typecasting. This is called typecasting. So this is sum is an integer. When you put it type like this, it is called typecasting. So what happens is this sum value will be considered as a double value. Double value. Automatically, double by integer is double only. It will be treated as double. You will get a fractional value. If you want, we can try some other input. We try some other input. 35, 37, 37, 43, 49, -1. So you'll get, okay, 10, 11, -1. So 10.5 is the answer, right? The average of 10 and 11 is 10.5. So yeah, like this. So I will stop here. Stop here. Thank you.